Hello, we are still looking at Chapter 2. We are still dealing with ratios, proportions, percentages, and solving simple equations. When we're solving for x, we're solving a simple equation. In this case, we're solving for x because x is our answer. So we're not having to do simple algebra to find x. So it's just real simple. If we look at number 10, just real simple, don't overthink them. We're just doing 100 over 200 times 1. And if you remember, anything times 1 is itself. So this would just still be 100 over 200. And then we have this little rule that when we have a 0 on top and a 0 on bottom, for every 0 I have on top, I can cancel a 0 on bottom. So they have to match. It's a 1-to-1. So if I got 1 0 on top, I cancel 1 0 on bottom. 2 zeros on top, I cancel 2 zeros on bottom. And that's how I reduce that. That's the same thing as dividing by 100 on top and bottom. So then 1/2 is my answer, so 1/2 equals x. Okay. So that was kind of simple because it was times 1. But when you look at 11, it's not any harder if you don't overthink it. We're still looking at just the 3/5 times 2. If we look at just this, it's a fraction times a whole number. We know what to do. We make our whole number over 1. Look to see if I can simplify anything. Nothing simplifies, so I multiply straight across. So 3 times 2 gives me 6. 5 times 1 gives me 5. Depending on how they want your answer, you can leave it as 6/5, or you can reduce, or you can not reduce it, but change it to an improper, or a mixed number. Well, I'm getting strangled on my words. So 1 1/5 would be my mixed number. So depending on what the question's asking, both answers are correct. All right, now let's look at number 12. This one's a little more, not complicated, a little more time consuming because I've got the complex fraction. I got the 1/6 divided by 1/4, because remember this little fraction bar here means divide. So I'm going to deal with just my complex fraction first, and I'm going to take 1/6 divided by 1/4, do the KFC, keep flip change, so I keep the first fraction, change my division to multiplication, flip my second fraction. And then I know my 6 and 4 reduce. They're even. So 2 goes into 4 2 times. 2 goes into 6 3 times. Multiply straight across to get 1 times 2 is 2. 3 times 1 is 3. And then I can't forget my times 5. And since 5 is a whole number, I'm going to put it over 1. Again, I'm going to look to see if anything cancels. It doesn't. I'm going to multiply straight across. 2 times 5 is 10. 3 times 1 is 3. So I can have 10/3, or I can make it a mixed number. I can have 3 1/3. Remember, you can stop these videos at any time and pause and write it down. You can also rewind the video. Okay, so 13, we're doing the same thing as we did with number 12. It's just a little bit different. We still got the complex fraction here. I'm still going to take and do 1/10 divided by 1/15. Still going to do the KFC. 1/10 times 15 over 1. This time I know that 5 goes into both of them. So I'm going to do 5 goes into 15 3 times. 5 goes into 10 2 times. And when I multiply straight across, 1 times 3 is 3. 2 times 1 is 2. I can't forget my times 2.2, so I'm going to bring it over here, and I'm going to put 2.2 over 1. And then I can reduce this also. I know that 2 goes into 2 one time. And since this has a decimal, since it's 2.2, make that look more like 2.2, then I know 2 goes into 2.2 1.1 times. Okay? And then I can multiply straight across. 3 times 1.1 gives me 3.3. 1 times 1 is 1. So it's just 3.3 equals x. So really what we're doing is the same thing we did when we multiplied and divided fractions. We're just taking and putting it all together into solving one problem. So we're taking sometimes our complex fractions, so we have to divide first and then multiply. Sometimes we're just going to multiply. In this case, I've got to get rid of my decimals, or at least my decimals in my fraction. So with this one, I've got, if I want to get, I can either change the denominator to a whole number by moving it just 2 places, but I still end up with a decimal on top, and that's fine. But I can move it 3 places, so it means I'd have to move the bottom of 3 places and add a 0, and I can have 125 over 250, and I don't have any decimals, and then times the 1.5 over 1. I don't have to worry about the decimal here, because I'm just going to multiply to that one. Now, if you think about quarters, you can reduce this by 25, but you can also look at it as $1.25 and $2.50. You know, $1.25 goes into 250 2 times, because 2 times 125 gives me 250. So I'm going to divide this one by 2. Oh, sorry, take that back. Divide this one by 125, and then I'm going to divide the 250 by 125. So I'm going to have 2 here and 1 up here. So then I get 1/2 times 1.5 over 1. So then I get 1/2, whoops, just fixing to write the same thing a second time. So multiply straight across, so I get 1.5 divided by 2. And since this has a decimal, I'm going to go ahead and divide it out. So 2 goes into the 1.5. I'm going to go up here and do that. 2 goes into the 1.5. Decimal goes straight up. 2 doesn't go into 1, so I add the 0. 2 goes into 15 7 times, because 2 times 7 is 14. I'm going to add a 0. Well, first I needed to subtract 15 minus 14 is 1. Then add a 0 and bring it down. 2 goes into 10 5 times, so that gives me 10 with a remainder of 0. So I can stop there. So this equals 0.75. So x would equal 0.75. Okay, so sometimes we have to use several things, and we use everything that we learned before. That's one thing about math, it builds on itself. Okay, so if we look at 15, and I'm going to draw a line here separating those two. If I look at 15, then I have 3/4 times 45%. Now I can change my percent to a decimal by moving the decimal 2 places to the left, or I can change my percent to a fraction. It's up to you which way you want to go. Personally, me, since I'm dealing with a fraction, I'm going to take my 3/4 and then change my percent to a fraction, make it 45 over 100. Then I'm going to simplify my 45 over 100. So remember, I'm dividing it by 5. So I have 3/4 times 45 divided by 5 is 9. 100 divided by 5 is 20. So if I can cancel, 3 doesn't go into 20, 4 doesn't go into 9. So I can't cancel anything. So I'm just multiplying straight across. 3 times 9 is 27. 4 times 20 is 80. Now, unless it says write it as a decimal, you don't have to worry about it. You can leave it as a fraction. and I think this one just said solve for x, so I don't have to worry about that. Okay, so let's look at these next ones. With the same thing here, I've got 75 over 125 times 5. I'm going to go ahead and reduce my fraction here, and I know 25 will go into both of them. If I didn't know 25, I could do 5. So I'm going to divide both of them by 25. So 75 divided by 25 is 3. 125 divided by 25 is 5. Because look at that, is how many quarters is $1.25. So I've got 5. And now I'm going to bring this 5 down as 5 over 1. And then I can cancel one more time. 5 and 5 just completely cancel. Have 1s out of them. And so I'm going to end up with 3. So x would equal 3. So sometimes they can be real simple. They can look really hard and end up being really simple. Okay, so we've done one like 17. We've done one like 18. I'm going to go ahead and skip those two. The answers to those two are in the solutions. It's in the module. And I'm going to do the 75% over the 60%. And the thing we can do here is just like canceling zeros. If I have a percent on top and a percent on bottom, my percents will cancel. Because remember, to get rid of the percent, I've got to divide top and bottom by 100. Same thing. So I've got now 75 over 60 times 1.2 over 1. Now I'm going to simplify, or I can simplify the 75 over 60, or I can get rid of this decimal. So I don't care how you do this. I'm going to show you how to get rid of this decimal, and it'll make it a little bit easier. So I'm going to keep my 75 over 60. And if I move this decimal one place, then I have to move the one on bottom one place, which means I have to add a 0 because it comes after the 1. So now I have 12 over 10. Now, I know, and the reason I did this, I could see it, but I know that 12 goes into 12 one time, 12 goes into 60 5 times. So now I have, multiplying straight across, 75 over 50, and now I know 25 goes into both of these. So 75 divided by 25 is 3, 50 divided by 25 is 2, or it could be 1 and 1/2. So it just said solve for x. So we'll just go ahead with 1 and 1/2 equals x. Okay, let's look over here at 20. And I want to do my canceling of zeros. Of course, some of you can look at that and say, okay, that's 1 million, that's 250,000. I know if I multiply 250,000 times 2, I'm going to get 1,000,000. So I'll have 2 on top. But if we cancel zeros, this is why other people are going to look at it. Okay, so that 0 cancels that. This one cancels this one. This one cancels this one, so 3 cancels 3. I have 1 here, cancels 1 more. Now I'm left with 100 over 25 times 5 over 1. And then I can do it 2 ways. I can do 5 into 25. That would reduce. I can do 100 into 25. So if I reduce this here, now look at it. It's how many quarters is in $1? There's 4 quarters in $1. So I'll put 4 over 1 times 5 over 1 and equals 20. So x equals 20. Okay, I'm going to stop here, and then I'm going to come back with number 21.